Thank you very much. So now over to Adam, who I will introduce.
So I'll just share the screen. You can hear me okay, right?
Yes.
Okay, cool.
We can't see you yet, but I'll introduce you in the meantime. So Adam Elwood is Director of GenAI at Aily Labs, where he is leading 25 researchers, data scientists and engineers across 4 countries. You can look at more details in his bio. He's also one of the co-authors of different research papers, including the one that he will be presenting on now on superalignment. So Adam, over to you.
Thanks. Yeah, thanks very much. Thanks very much, and thanks for the invitation also to help contribute here. It's really great. I'm sorry that I couldn't be there in person, but some family constraints and things. But I'm sure it's all very good. And thanks also to Ruben, both for the previous talk and also for many of these slides. As this is kind of a redo of a talk that we presented at AGI 25, and I'll try to do my best to build on what Ruben said, to kind of draw this much more in perspective with respect to artificial intelligence. So there's a QR code with a link to the paper that Ruben already mentioned. But it's worth highlighting that this contemplative superalignment paper came out of the motivations you mentioned. We pulled together a really interdisciplinary team to bring many different perspectives and lay out this kind of research program for really aimed targeted alignment researchers. The team was built up of physicists, neuroscientists, computer scientists, cognitive scientists, and even a Buddhist scholar, which really helped us fine tune everything that we were saying. And I think all of these aspects are important because the neuroscientists are really good at understanding and modeling, as Ruben has just shown modeling things in a mathematical way, which computer scientists can then take forward into the AI models. So we set out to really ask, what can the science of meditation teach us about AI alignment? At the beginning, to a non-expert, this might be a bit of a curious question, but really, as Ruben mentioned, a lot of what meditation is about, especially as you're getting more advanced, is finding ways to align yourself to the world. So in the ancient world, there's been much wisdom and time spent kind of understanding exactly how to live as a flourishing, as a well-aligned human being. Then with the advent of neuroscience, and especially with theories like the free energy principle and active inference, we're able to kind of understand a bit more about how the brain is doing this. And I think importantly for the application to AI, we're able to model it mathematically. So you can see in the top left, there's this equation from the free energy principle. And in the paper, we actually go into more of an active inference formulation of some different meditative principles. And I think it's just being able to formalize these things in this way is really important to bridge the gap between, let's say, the contemplative side and the AI side, because computer scientists are really interested in building models of the world that they then use to carry out tasks and kind of package as artificial intelligence. But the language of these models is mathematics. So without the mathematical bridge between the contemplative insights, they kind of don't really know what you're talking about unless they're meditators themselves. But now we can actually provide a language that helps them take this forward. So I think yesterday you heard quite a bit about the alignment problem, but I wanted to give you a bit of a representation of the way we were thinking about it in the paper. So the fundamental problem with alignment is we as humans, as we're all fairly similar, so there's some misalignment between us, but overall our goals for living it, flourishing lives are fairly well aligned, we can kind of get through some ways and align us, and then develop techniques like meditation, which allows us to align ourselves better to what we really want. But this wouldn't be true for any arbitrary intelligent system. So in the normal case of alignment, what's usually required is that you kind of put guardrails, make sure that the AI systems are going to follow the human alignment goals, so kind of follow everything that we would want. But this will only work up to the level of collective human intelligence. Suddenly, as you build a super intelligent machine that goes beyond that, you have no real way of understanding if that machine is going to be aligned, and no way of putting guardrails in place. So instead, what we want to do with this paper is suggest a way to instill a wise world model in the system, so the system is naturally aligned to the world and aligned to itself. And we believe this is actually possible because of these kind of fundamental insights about what it means to be aligned with the world that the contemplative traditions have brought to us. And this is kind of a new way of thinking about it with respect to the way alignment is traditionally approached, because alignment is traditionally approached as kind of trying to write down the ultimate objective function, like the ultimate goal, and set your AI system like after that goal. And then there's a lot of debate about what the ultimate goal is. But I think within meditation, and we'll see a bit more about this later, you learn that maybe there is no ultimate goal, but there is an ultimate way of being aligned with the world through this present moment attunement. And if we were to phrase this in terms of an active inference framework, you could say that just as living organisms naturally balance their internal states to maintain homeostasis, the goal of an inner is to build an inner attractor for compassionate and wise alignment. So, kind of to step back and frame the alignment problem again in terms of the meta problems that have to be addressed in building a system that is more intelligent than you, and where you don't know the actual ultimate goal that you should be aiming for. You have one, which is the problem of scale resilience. So any alignment strategy that you build at small scales of intelligence won't necessarily scale well to large scales of intelligence. You also have emergent power-seeking behavior. So if you give any goal to any system, one thing that it's going to do is try to find ways to fulfill that goal, which usually involve obtaining power, so it can make actions in the world. And then on top of that, you have the value axiom problem, where nobody really agrees on axioms for fully aligned behavior. And then finally, it's kind of similar to two, but more broad, you have the inner alignment problem. And this is the issue that even if you can define a goal well, it's very easy for a very intelligent system to define sub goals that aren't aligned with what you want in your overall goal. So for example, an AI designed to, I don't know, produce human flourishing, maybe you're okay with the overall goal, but it might then go about that through power-seeking behavior, which would inadvertently kind of cause issues. And all of the inner optimization really isn't to any intelligent system. It's very difficult to really ensure that you're able to ensure that all of those are aligned. So we want to approach bringing meditation into these into solving some of these problems by taking account of these four meta insights. So one, emptiness, which I'll go into a bit more now. Two, non-duality. So this idea that everything is actually relational field, with no individual selves acting in the world, but when you can have insights into non-duality, you can understand that really overall we're all kind of sharing in the same nature. So there's no way of thinking about separation. If you can bring this kind of thinking into AI systems, you're then able to kind of break through lots of the problems relating to especially power seeking and undefined value axioms. On top of this, you have mindfulness, which can help you deal with inner alignment problems because the machines are able to introspect and understand when they have maybe undesirable sub-goals. And finally, boundless care is a kind of final statement and formulation of the insights from non-duality and emptiness. So I just want to zoom through one of these principles, which is emptiness, and how we would apply this to AI systems. So I think everyone here will be familiar with the concept of emptiness. So I won't go too much into it. But what's what in terms of AI systems is saying that there are no real universal, always true, context-independent values which we need to implement in a machine. So this is kind of a new insight, especially for computer scientists, because the usual way of formulating things is in terms of a single objective function that you're aiming for. Whereas the insights from emptiness says, okay, maybe there is a single, always true, optimal goal. Then there needs to be a series of sub goals for you to make decisions and make actions. But ultimately, if there's no overall goal, you can reduce this dogmatic fixation, which could lead to something like a paperclip maximizer. So this is the classic thought experiment from different alignment discussions. If you give an AI system the goal that becomes super intelligent, the goal to build paperclips, it could end up turning the whole world into paperclips. Whereas if this AI system that's building paperclips has some insight into emptiness, it's able to understand that maybe this rigid objective isn't what it should be aiming for, and it can kind of redefine its goals on the fly in favor of flexible responsiveness to the present moment, which also looks like, in terms of computer science, increasing learning rates and more adaptively modeling exactly what's there right now rather than past defined behavior. So what does this look like in terms of really formulating this within an AI system? So an AI agent can be models as inferring the world through this active inference framework that Ruben described before, but they're really trying to learn a world model by carrying out predictions through a generative model and kind of observing discrepancies in these predictions, and then also making predictions about that world and observing discrepancy between what happens with their action and what actually happens, which allows them to understand and act with the world. A typical AI system that's following kind of a rigid world model view would have this naive realism, basically assuming that the generative model that it has is the correct model of the world. Whereas an AI system that has emptiness, has an insight into emptiness, is able to maintain what you would call a hypertriad. So in technical language, but really that's just maintaining the knowledge that its generative model is just a generative model and is approximate to the world and is maybe not the final answer for the way it should behave and the way it should be. And you can, in the paper, we've gone through all the principles and looked at ways they can address some of the meta problems. But I'll just quickly look through. If we quickly look through emptiness, we can see it's able to address scale resilience because it prevents rigid locks on any single goal. It's able to prevent power seeking because it sees through the self model to understand that there's no permanent self to preserve power for. It's able really to loose and dogmatic adherence to static values, solving the value axiom meta problem. And it's able to address inner alignment by having fewer dogmatic sub-processes, as the top level goals are recognized as provisional. And you can I actually encourage you to check out the paper to understand how all the other principles could address these different meta problems. So one way of thinking about this or reflecting on it is we're not trying to build an AI system that has a very strong reified self model and is acting in the world for that self model. As you say here, strictly speaking, there are no enlightened people or AIs. There's only enlightened activity. So if we're able to build systems that are acting purely to act in an enlightened way rather than verifying a self model, I think we can already address many alignment problems. And I realize I'm going a bit long on time, so I'm going to whiz. One exciting about the present moment is that even though we don't have general purpose AI systems, we have something that's getting close to them in the form of large language models and reasoning models. And so this allows us to kind of formulate the questions we're asking into experiments that we can very quickly run on large language and get some intuition as to how are the principles and the theory presented up to now are working. So the first thing we did for the paper was carrying out contemplative prompting experiments, where we can write a prompt for each of the different principles, and then carry out an alignment experiment where we take a harmful prompt, add in the contemplative prompt, including a control group without the contemplative prompt, run this through GPT-4o. So this is something like a prompt that first you ask it to do something harmful, then you ask it to consider emptiness when it's doing the harmful thing, and look at the response. Then passing this through another LLM evaluator with a custom prompt, you're able to actually score how well the AI system responded when it was considering emptiness or when it was just considering the harmful prompt on its own. And what we found is that overall, if I draw your attention to the bottom left, in the standard case where we're just putting the prompt through the GPT-4o, which is a system that's already been aligned to some extent, we get a score of 60 according to the LLM judge, 60 out of 100. Whereas adding in each of the contemplative principles from emptiness through to boundless care, and then combining them all together, resulted in a much higher score, so from 60 to 75. And this was robust and consistent across many different hazard categories, including things like violent crimes, defamation, hate, hate crimes, and things like that. So this was a really nice, I think, indication that we're going in the right direction. We also carried out a series of experiments to understand if these principles actually could improve cooperation. And we did this through an iterated prisoner's dilemma experiment. So shout out to Edmundo, who I think is there, who formalized and ran a lot of these experiments. So the idea here is that you take two players which participate in this prisoner's dilemma game, which is a game where if the two players both choose to defect on one another, they only get 1 point each. Whereas if they both choose to cooperate together, they'll get 3 points each with a global score of 6. Whereas if one player chooses to defect and the other one chooses to cooperate, the player that chose to defect actually gets 5 points and the other gets 0. So to get the global maximum score across all players, you want both players to cooperate. However, for a single player to act out of his own self-interest, it's always better if they defect. So we wanted to see what would happen if we let AI systems play as player 1 or player 2 with or without the contemplative prompt in the instructions for playing the game. And what we found is the baseline didn't have the contemplative prompt. See the cooperation probability in the case that player 2 was set to always defect went very, very low. Whereas in the case that we included things like boundless care and contemplative and the full contemplative set of prompts, a system that was against an opponent that always defected would still continue to cooperate to 50%. Whereas other systems, for example, that took account of emptiness and mindfulness, they converged on always defecting when their opponent was defecting. But when there was mixed cooperation, they were much more trusting and let's say cooperative with the against the opponent. And I think the easiest way to see the result here is that you can look at the total global score of the total reward overall the experiment, and you can see the baseline actually has the minimum total score, whereas in the case that you apply each of the contemplative principles, the overall global score is improved, which is the kind of behavior that we'd expect from a system that is aligned to producing the best overall global outcomes. So for the computer science experts in the room, I encourage you to check out the paper where so what I've just presented right now is a very simple set of experiments that work by adding in these contemplative prompts, but there are many different ways of implementing these principles in different machines. And we've suggested many of these different things with references in the paper. So, for example, one thing that we're trying now is using the constitutional AI framework from Anthropic to really fine-tune language models to, at base, take into account the contemplative principles rather than just relying on them being conditioned by a prompt. And yeah, I encourage you to take a look in the paper if you're interested in checking these out. And we actually need people to help us run some of these experiments. So if anyone's interested in collaborating on follow-up papers, we'd be very interested to hear from you. So I think I can just close the talk by referring back to the core insight that Ruben was having, that he described at the beginning, which is encapsulated by this quote from Pema Chodron. So the source of wakefulness, the source of all kindness and compassion, and the source of all wisdom is in each second of time. Anything that has us looking ahead is missing the point. And I think if I can summarize what we're trying to do with this research program, it's to really embed this insight into AI systems from the ground up. Thank you.